All right, moving right along to exit slip 5. Just kind of putting all the formulas together here. Let's get started. Numbers 1 and 2 want us to find the surface area of each right prism. It's important to read the directions so you know what they're asking you to find. Leave all answers exact with reduced radicals and in terms of pi, meaning no decimals. And of course, remember your labels, your units. So let's take a look at number 1. So they're telling us, they told us in the directions that they're prisms. So we're looking for those two congruent parallel bases. So in number 1, our two congruent parallel bases are these triangles. And in the front base, they have all 3 of the sides marked. So our base is an equilateral triangle. So I'm just going to mark my equilateral triangle. All 3 sides are 6. So when I'm calculating my perimeter and the area of my base, there are 3 sides, each of them 6 meters long. So my perimeter is 18. The area of my equilateral triangle, I'm going to use side squared root 3 over 4 and plug in 6 for my side. 6 squared root 3 over 4. 36 divided by 4 is 9. So the area of my base is 9 root 3, and the perimeter of my base is 18. I'm going to use those when I'm calculating my surface area. There are 2 bases, and then the lateral area, the pH. I just calculated what B and P are, so I'll plug those values in. The area of the base is 9 root 3. The perimeter of the base is 18, so I can plug those in the right spots. Then I need to find the height of the prism. So the height of the prism is the distance between the 2 bases. So if we crossed off the 6, the values we used for the base, 12 is the only one left over. That is the height of our prism. So now we have all of the variables plugged in with their values, and now we can compute. So 9 times 2 is 18 root 3. 18 times 12 gets us 216. We can't combine these because the root 3 is a different, they're not like terms, if you will, so we're going to keep them separate. So our total surface area is 18 root 3 plus 216. This is square meters. They did have an answer blank for the lateral area, so it's super easy for me to go back, identify my lateral area as 216 square meters. All right, let's see how number 2 goes. So again, directions told me that this is a prism, so I need to find my 2 congruent parallel bases. In this diagram, the bases are these trapezoids. So before I start with my surface area formula, I need to focus in on these trapezoidal bases. So our base is a trapezoid, which makes this a trapezoidal prism. If I draw them in the same way that they appear in the diagram, it does not look like it doesn't look like it's an isosceles trapezoid because the 2 legs are 9 and 7. So the 9 over here, the 7 over here, remember the bases are congruent. So those 2 are both 9, these 2 are both 7. And then this top base and bottom base. These would be the parallel sides. And luckily for us, they gave us the height of the base. The height of the base is 6. So when we're calculating the perimeter, we're going to add up all the sides. So 8 plus 9 plus 12 plus 7. We're not going to add the 6 because we don't include the height in our perimeter. But our perimeter is 34. The area of the base, the area of our trapezoid is 1/2 times the height of the trapezoid times the sum of the bases. So the height of our trapezoid is 6. The 2 bases are 12 and 8. So when we multiply all that through, we get that the area of our base, let's see, this is 20 times 3 is 60. So now we have the B and the P that we can include in our surface area formula. So surface area of prisms, 2B plus pH. Again, we just calculated the B and the P. The area of our base is 60. The perimeter of our base is 34. And so now what we need to do is find the height of the prism. So I'm just going to go ahead and simplify it. A lot of markings here on the diagram. There are 2 ways to think about it. One, the definition of the height of our prism says it's the distance between the two bases. So the distance between those two trapezoids is 10. If visually that's hard for you to see, which I totally get because there's a lot going on in this diagram, if you cross out the dimensions that you used to find B and P, so the 7, the 8, the 9, and the 12, if you cross those out, and the 6, the only number left over will be the height of your prism. So that's just kind of a nice way to confirm that you identified the correct number for your height. So now we go through the two bases, 120 and then plus 340. So our total surface area is 460 square inches. So 460 square inches. Again, to get the lateral area, just have to go back in. Ignore the bases this time. They just want the lateral area, 340 square inches. All right, those are our two prisms. I hope those made sense. Let's move on down. We're looking at number 3, a pyramid. So this one's pretty obvious that it's a pyramid because that one yellow shaded hexagon at the bottom and then the shared vertex up at the top tells us that this is a pyramid. And we have a regular hexagon here. So the perimeter, each of the sides are 4. So there's 6 sides, each of them 4 centimeters. 6 times 4 is 24. And the area of our regular hexagon, there are 6 equilateral triangles. So 6 times side squared root 3 over 4. The area of our base comes out to be 24 root 3. So now we have our B and P. We can jump right into the surface area formula. So for pyramids, there's only one base, and the lateral area, we compute 1/2 times the perimeter times the slant height. So I'm going to put my parentheses in where they belong for all my unknown values. We just calculated the area of the base and the perimeter of the base, so I can plug those in. The only thing we need from here is the slant height. So I have to look at my diagram. Again, luckily, they give us the slant height. In this case, the slant height is 18, so I'm going to plug that in here. And now I can just multiply through. So 24 root 3 plus 1/2 times 24 times 18 is 216. And this would be my total surface area. I can't combine those because the root 3 can't combine with the 216, so we just leave them separate. And then to identify the lateral area, it's just this portion of our formula, so 216 square centimeters. All right, moving right along, I'm just gonna scooch this over so we have more room for this composite figure. All right, number 4. So again, composite figure, things that are stacked on top of each other. First thing you want to identify is what's being stacked. So I see that we have a cone here and a cylinder here. So that's how I'm going to break up my work, cone plus cylinder. Since we're stacking them, we will be adding. All right, so when we're looking at our cone, we're asking, are we finding the entire surface area of the cone, like the base and the lateral area? Well, oops, pi RL. Because the base is being stacked, we won't include that. So we're not going to include the base. We just want the lateral area of the cone, which is the pi RL. When we look at the cylinder, are we including the entire surface area of the cylinder, the 2 bases and these and the lateral area? Well, the 2 bases, are we including both of them? Well, we're not including this one because that's going to be the one that's stacked. But this one on the right side, we will paint that. So instead of having 2 bases to paint, we are just going to paint one of the bases and the lateral area. So we're going to combine these two. All right, so again, make sure you have a plan that's organized and clear, have your formulas written out. You get points for showing me what you know, so definitely don't skip these steps. They're super important and will hopefully make it a lot easier for you. So I'm just going to go through, and wherever I see an unknown value, a variable, I'm going to put parentheses so I know I need to find that. Luckily, there are 3 of these values that will be the same, which is the radius of the circles. So the radius of the circle goes from the center of the base to the side of the circle. That happens to be a part of this right triangle here, which is a 6, 8, 10 right triangle. So our radius for all three of those is 8. All right, so I'm just gonna go one by one. For my cone, I need the slant height. The slant height is the slanted portion of our cone, which they'd give us as 10, so that was nice and easy. And now we need the height of the cylinder. So the height, remember, is the distance between the two circles, which is 12. So I can plug those in here, and now I can just multiply through. So we have 80 pi plus 64 pi plus 2 times 8 times 12. Sorry, I don't have my answer key here. 192 pi. And so then we're just going to multiply, or I'm sorry, now we're going to add 80 plus 64 plus 192 gives us 336 pi. That is our total surface area. Can't forget our units of inches, so square inches. All right, feel free, you guys, to rewind, pause, go back, listen again, and let us know if you have any questions.